an important problem from probability distribution of one dimension. And the problem is, a point is chosen at random on a semicircle having center at the origin, okay, and radius unity, and project on the diameter. Prove that the distance of the point of projection from the center has probability density, which is given by 1 by pi into root under 1 minus x square for minus 1 less x less 1 and 0 elsewhere. Okay, here we use two important results of probability. The first one is rectangular distribution or uniform distribution, and the PDF of this distribution we know this is fx, this is equal to 1 by b minus a less x less b, and this is 0 where elsewhere. Okay, this is known as uniformly distributed in the open interval AB. And the second one is the transformation of continuous random variable. This is also an important theorem of probability. If capital X is a continuous random variable having PDF fx, and a transformation is given which is given by y, this is equal to phi of x, then y is also a continuous random variable. And we find the PDF of y using this formula. This is gy equal to fx into mod dx dy. But two conditions must be satisfied there. The first condition is phi x, this phi x must be differentiable, and phi dash x must be keeps same sign for all value of x. Okay, if we want to see the total proof of this theorem, then we use search the playlist of the one dimensional distribution of probability in my channel. Okay, now to solve this problem, we first draw a rough sketch of semicircle. Let this is the semicircle, and the center, this is the center O, and it is given that this is the origin. Okay, and let this is A and this is A dash. This is the diameter. We first consider a random variable which is given by theta. Okay, which is given by theta. We first let angle AOP, this is equal to theta, and here theta is a random variable which is uniformly distributed in, here theta is 0 if P on the line OA. Okay, so theta is distributed in, theta belongs 0, and if we take P on the line OA dash, then this is pi. Okay, so uniformly distributed in the interval 0 to pi. So PDF of theta is f theta, which is given by 1 by pi minus 0 for 0 less theta less pi and 0 elsewhere. Okay, we use the rectangular distribution or uniform distribution here. Now here it is given that this point P is projected on the diameter. So we project this point on the diameter, let it be Q. Okay, and we have to find the PDF, probability density of the distance of the point of projection from the center. So we have to find the probability density of the distance OP. Here it is given that the radius of the circle is unity. So if we take this distance OQ is capital X, here we write let OQ, this is equal to capital X, and is a random variable, and the range of the random variable is, if we take the point P on the right side of O, then this variable is 0 to 1 because the radius is unity, and if we take P on the left side of O, then it is from 0 to -1. Okay, then we say that then -1 less x less 1. This is the range of the random variable capital X. Okay, now from the triangle OPQ, and this is theta, we get from triangle OPQ, we get this is x, this is 1, and this is theta. And clearly by property of triangle we can write this is cos theta, this is equal to cos theta, this is equal to base by hypotenuse. This is x by 1, and theta, this is equal to cos inverse x. Okay, now in real variable, theta, this is equal to cos inverse x. Now differentiation of theta with respect to x is given by d theta dx, which is given by 1 by -1 by root under 1 minus x square. And clearly this is always negative. This is always negative for all x in -1 to 1, because the range of x is this. Okay, so it gives constant sign for all value of x or for all value of the random variable. So we can use the formula of this transformation of random variable. So the PDF of capital X is, this is g of x, which is given by f of theta into mod of d theta by dx. Okay, using this formula here we write x in place of y and we write theta in place of x. So we get 1 by pi, we already get here, this is 1 by 5 into the value of this is given by mod of 1 by root 1 minus x square. So this is 1 by pi into root 1 minus x square, where the range is -1 less x less 1, and otherwise or elsewhere this is 0. Okay, so we prove our required result. This is 1 by pi into root under 1 minus x square for this range and 0 elsewhere. This is very important type of problem from probability distribution. Right? Thank you for watching.